Welcome back. In this video, I'll look at some commonly used syntax parsers. We'll start with Stanford. I'm here at stanfordnlp.github.io/CoreNLP. There's a link here to download it. A little description with some pictures talking about the pipeline and the different annotations that you can get. Notice also you could download CoreNLP for many different languages. CoreNLP is written in Java, and you should have at least Java 1.8. You can run it from the command line or from simple programs. There's also a demo in here where you can type things in and see what they look like. Here's where I downloaded Stanford CoreNLP, and you can see I have version 4.1. If we look inside there, you see a lot of jar files. You'll also see a sample script that you can run. Let's open that up. And this is basically telling you how you can run it from the console. Running it from the console like this will use these input files here. Notice the Stanford dependency manuals in here. And there's a program already written for you on usage in Java. So I'm just going to copy this code into an IDE. I'm in the intellij IDE, and we're going to need all of these jar files to be associated with this program. The way you do that, at least in intellij, you go to File, Project Structure, and this pops up. You want to go to Modules, then Dependencies. And notice I just linked in the entire folder so that any of those jar files could be used. This is Java, so it's verbose. Not a fan of Java, but here we go. First thing we're going to tell it is to set up the properties. Our annotators, we want it to tokenize, do sentence split, part of speech, lemma, named entity recognizer, parse, decoref, and sentiment. If you want to speed it up, you can get rid of this decoref. That seems to be really slow. Next, we're going to set up our pipeline. And we're going to annotate this text right here, these two sentences. I copied these from another parser's demo, so I'm just going to use the same two sentences in all of these demos here. And then you annotate. Once you annotate, you can just print stuff out. Top level annotation, well, let's just run it so you can see the length of time it takes to run it. It's adding each annotator. And I will say that over the years, they've rewritten this so many times and they keep making it faster. So it's pretty fast, even with the decoref. So here we are, we're already done. Let's see what we got out of here. Here's sentence number 1. Sentiment is neutral. This is just a fact to most of us. Barack Obama was born in Hawaii. Then for each of the tokens, it gives you the offsets, part of speech, lemmas, named entity, and sentiment class. Here's our phrase structure or constituency parse. This is how we normally look at the constituency or phrase structure grammar parse. This binary one here, it seems to be the purpose of that is so that it can be annotated with sentiment. Here we have our dependency parses. Named entity, we have a person, and we have a state or province. Same thing for sentence 2, tokens, constituency parse, sentiment, dependency parse. We only have one named entity, that is the date here. And then we have the co-reference. This is the part I said that takes a long time, so if you're not using it, you'd want to take that annotation out. And what it tries to do is link up in the second sentence, he. What is that referring to? It's referring to Barack Obama. So this is really helpful because we use pronouns a lot in sentences in English. And a lot of downstream NLP applications will do a lot better if you could replace a pronoun with an actual noun or proper noun. There are a few Python wrappers of CoreNLP. Stanza is the one that is considered the official Python library. I've already shown you how to download CoreNLP, that's the first thing. And then you have to pip install Stanza. Here's a link to the documentation. So once we've done that, we can just import it. This line of code right here, you'll need to run once and only once. So I have that as raw instead of executable code here. And after it runs, it will tell you where it downloaded the resources. For me, it downloaded them right here. Let's set up the pipeline for English. And it tells us all the different components that it loaded. Here's that same text. And I'm going to send that through the NLP function to make a doc. This syntax is very similar to Spacey. Now I'm going to iterate through the sentences, the two sentences in that doc. And I'm just going to print the dependencies. So here are the dependencies for sentence 1, and the rest are for sentence 2. Such a small amount of code to get exactly what you want if you're looking for a dependency parse. And you can also do this in a server. So I'm going to start the server. This code right here I need for the server to be able to find where I have Stanford CoreNLP downloaded. This is how you do it for a Mac. Your path, of course, will be different, and this would be a little bit different on a Windows computer as well. This with construction is nice because it will ensure that this server that we're going to fire up here, let me go ahead and hit play. The with construction will make sure that when we exit the notebook, it will shut it down. Let me view my left sidebar so you can see the servers over there. That takes a minute to run. Okay, so now that's run. I'm just going to iterate through the sentences and print out this information here. Now let me shut down the notebook. You see my server there. In a minute that will disappear. Ah, there it goes. Spacey is a really nice, really fast, what they call industrial strength NLP framework. You can read installation instructions here, learn about Spacey, some of the features, who all's using it, quite an impressive list there. You can install it with pip or pip3. If you're lucky enough to have a GPU, there's some special instructions you can follow to link it with your CUDA library. After installing Spacey, you want to download at least one pre-trained model. There's 3 of them. And you do this at the command line like this. Python or Python 3 -m Spacey download en core web SM for the small model, MD for the medium model, and BG for the big model. I downloaded all 3 of them. The bigger the model, the more accurate the results, but also it can be a little bit slower. Here I'm importing Spacey and then setting up NLP to be the medium model. While that's loading, notice that the text is the same text we've been looking at. And we will create an NLP object called doc. Now I'm going to iterate through all of the tokens here. I'm printing out some of the attributes of each token. First of all, the token, the lemma, part of speech, whether or not it's alpha, whether or not it's a stop word, and here's a couple of other attributes we could print out as well. Before we get to the dependency parse, let me just show you some other things you can do in Spacey. You can extract noun phrases, verbs, not sure where it got bare, named entities, and here are dependencies. The root is born. Okay, so that's how they got bear out of born. Interesting. Spacey also has a nice visualization. Here we kind of have to scoot back and forth. So what I did in this one is go through each sentence, doc.sense, and render, that way it's kind of up and down. So here is the dependency parse for the first sentence. We've got our root, we've got our prepositional phrase, we've got our auxiliary in the passive construction, and our subject, which is also in the passive construction. Pretty nice visualization there. Next, we're going to look at AllenNLP. And remember, in our demo for this sentence, we can also look at usage. So this is where I got the code for my notebook here. I have the text, setting up the predictor, putting the predictor results in a variable so I can look at the keys and see what I might want to pick off. And we see here the parse of that sentence. If I want a cleaner output, I can just get our first verb here and the description attribute, and that's a little bit easier to read. In the GitHub, I have a PDF that tells you how to use Senna. Senna stands for Semantic Extraction Using a Neural Network Architecture. It's a really fast SRL parser that was trained on Wikipedia. You can download it here. This is the page it links to, and here's the download link. And here's a little bit more information about how you specifically run it for the 3 different operating systems. So in my example here, I'm running it from the console. This is just kind of a sanity check you can do to make sure that it's installed correctly. Running Senna, and you'll replace Senna with the Linux, Win, or OS X, depending on what system you are. And I like this POS VBS flag. If you leave that off, it will completely ignore the verb be, which in this sentence is the only verb, and so we actually wouldn't get an SRL parse. And there's some other flags that are useful, but I always use this flag. This is how it prints out. It prints out the tokens, the part of speech, the chunking information. This will be non-zero for any kind of named entity. And over here you have the constituency parse. This is a chunking notation, B, I, and E, that shows the beginning of the noun phrase, and then multiple words could have the I and then the end. Here we have a noun phrase of just 2 tokens, so there's no I in there. Backing up a bit to his main page, we see that he's currently a research scientist at Facebook. When he wrote Senna, he was a researcher at NEC. I'm not going to make a comment about this pose because, after all, a man's smarter than I am. Look at all of his research papers. Quite impressive. In 2011, here's the paper for Senna. If you want a very meaty read, you can see it was a team effort. I downloaded Senna. You can see it. I put it in my root folder here. And then I unpacked it. If we take a peek in there, actually look at the embeddings that were learned. We'll talk about embeddings later. He trained this on Wikipedia. And here are the executable files. I've opened a terminal there. I'm on a Mac, so I chose OS X. And here's my POS VBS flag. So this is basically waiting for me to type in a sentence. And here's our output. Tokens, part of speech, chunks. We got some named entities. For each verb, you'll get a column. So for the was, we got a column, and born, we got a column with the SRLs. They both have the same argument 1 of Barack Obama, and they both identified location as a modifier. And here's the PSG parse. We can get out of here with, I believe, Control-C. Notice that they provided a sample input and output. You could create your own. And this is the same command, Senna OXX, in my case POSVBS. Then I have, just like a typical Unix, the less than sanity test input. I just used their input instead of my own. And then I had it go to a different file, output.txt, because I didn't want to overwrite their file. Let's take a look at that. You can see it's quite a lengthy file here because we have 4 verbs. Again, for each verb has its own arguments. So said has these 2 arguments, signed has these arguments, extending has these arguments, and provide has these arguments. The way I have used this in a project is to either run this at the console first to get my output files, and then input this into a Python program where I can process and pick off what I want. I have some code in my GitHub here, Senna parse, which is several years old, so I'm scared to look at it. But basically what it does is we're going to have an input file, it'll segment that, run those sentences through the Senna parser, and process the output. So to do this, I used TextBlob to get the sentences, but to run Senna, I used subprocess right here. So this code right here you can look at if you want to run it from within a Python program. Some NLP projects won't need to do syntax parsing of sentences. They may just look at the words or n-grams. Other projects will need to glean information from the structure of sentences, and for that you'll need one of these parsers. The most popular parses for recent NLP projects are the dependency parse and the SRL parse. I used those in my projects back when I was working on my dissertation a few years back. And with the memories of my research fresh in mind, I'll leave you with this quote from Wernher von Braun. "Research is what I'm doing when I don't know what I'm doing."